Hello, Holly. Hey, Nicole, how you doing? Hi, Molly. Nicole, for you saying that this is new technology for you, it actually is really good technology to collaborate among a group of people. I'm using the broadcast so I can go to all the people in the class, but this technology allows 10 people to simultaneously have video up at the same time. Hello, Emily. There's at least 4 people that are going to be late to starting the class. So I'm gonna start probably, hopefully in about 5 minutes. We'll see how many people are logged in and then I'll get started. So if you're one of the people that came in early, maybe check back in about a few minutes. Hello, Kyle and Jeff. Hello, Russell. Hello, Sarah. Hello,
Hey,
Carolyn.
how are you? Good.
I'm talking to a class right now.
Okay. I just wanted to ask you, can you send me an email you have about the latest computer rotation?
You mean where we were at with who had what?
Yeah.
Yeah.
When you left off.
Yeah.
Okay. Thank you.
Okay, we're up to 8. There's 4 people that I know came to, I think 4 people that came to Millersville that are now driving home, and they'll be late. So I'm looking for about 6 or 7 more at least. Come on, folks. Okay, so Sarah, who else are you with, and are you guys going to participate from here at Millersville? Thanks, Matt. Hello, how are you doing? Okay, so Kyle and Jeff, hi. Okay, so I already got you on the list. Thanks, guys. And Caitlin. All right, so it's already 8 minutes after, so I know you guys are, there may, hopefully other people are trying to get online or trying to figure out what to do, and they will in the next few minutes. But I'm gonna get started. So what I've got here is, obviously you can see the video, and I'm gonna put up a PowerPoint here in a minute. Yeah, yes, somebody just said, is this, not sure if this is right. That is right. And so anyways, I'm going to put up a PowerPoint here in a minute. And so when I going through the PowerPoint, I had thought a lot about this lecture that I'm going to do tonight and the questions and discussion, because it's an abstract concept that I'm going to be trying to get across today. And it's one that requires some prior knowledge before you can really engage in the discussion. But it's a kind of lesson where we really need to discuss it. And so I spent a lot of time trying to figure out how am I going to make this work. So then when I thought it was going to snow, or think it is going to snow, or there's a winter weather warning, and we're doing it online, well, that just raises the bar quite a bit in terms of this challenge of creating a discussion around an abstract concept. So what I'm going to need you guys to do is really engage with the presentation. So I'm talking to myself right now, sort of, but as soon as we start into the lecture, I want you to write a question, write a response. Just put down something that's confusing you. And a lot of quick responses, and that's why I've got today's meet. So I don't know how you've got it set up, but I've got two windows set up where one window I can see myself on video right now, and next to it I've got today's meet. I've got a running log, so I can kind of see both at the same time, right? So since I've been talking, Frank, Lauren, and Diane have come in, and we're getting there. So I'm going to start with the lecture now. Can you guys hear me? If you can, just give me a quick note, and we'll just have a quick thing go and talk today's meet. Hopefully I'll see a whole bunch of people saying they can hear me. Okay, I don't see a whole bunch of people saying they can hear me. Okay, to Nicole, yes, you should see me. It really isn't that important to see me though. What might be important is viewing the notes that are on the PowerPoint. And so if you're not getting, if you or anybody else is able to hear but not able to see the video, what you can do is download the PowerPoint and follow along that way, and just make sure you're advancing the slides when I do. The PowerPoint is on D2L. It's in the content section of D2L, and I have it listed or uploaded in the section called materials used in class. It's at the bottom of the list, materials used in class, and it's for March 4th. There's the PowerPoint. There's also an agenda there that you could download as well, although, yeah, you're going to need the agenda later on. All right. Thank you guys for letting me know you can hear and see me. All right. So I'm going to start with PowerPoint. And again, you can download it if you can't see the video. All right, and I don't want to belabor this with by keeping asking you this, but let me know that you can see this PowerPoint right now too, and you're seeing the slide on meta-analysis. All right, I got Frank and Kim tell me they can see it. Seems like there's a delay between when I ask the question and when I see the text. I don't know if the delay is Google Hangout or today's meet, but it's significant, 30 to 60 seconds. Okay, so it's very small. Is this better? Let me try full screen, see how that goes. Well, I can't really do full screen because then I won't be able to see the notes. All right. What you might want to do is download the PowerPoint from D2L. All right. So I hope this is going to work. Okay. So first I'm going to start with, actually I want to talk about the goals for tonight. The big goal for tonight kind of builds on last week where I said we were going from describing studies to analyzing studies. tonight we're continuing with something we started earlier, which is trying to look at the big picture, not just analyzing one study at a time, but analyzing a number of studies at a time. And we're going to do that in 3 ways. First, we're going to be looking at meta-analysis and what does that mean. And so that's actually one way of looking at a number of studies at once is to look at one study that's a meta-analysis of others. Second, we're going to look at effect size, which is maybe a subtopic of meta-analysis. And third, we're going to talk about literature review, with the goal being tonight for you and your group members to start to think about how you would organize a literature review. Right? So we are using the technology to be synchronous here, and it seems like it's a little bit not perfect even here at the beginning when I'm broadcasting to many people. Later on, we're going to be collaborating with each other, so we're going to have to work hard to make it all work. All right, so we're going to start with meta-analysis, and I thought I would recap some basic concepts of meta-analysis, or really this may not be a recap. This may be really the first time I've presented it. I think we've had meta-analysis discussed, we've seen a video of meta-analysis, but never kind of step-by-step defined it. And I think we have to go back to that before we can really understand more about meta-analysis. All right, so the first thing to know about meta-analysis is, you know what, I'm sorry to interrupt myself, but never mind. There's a tool in Google Hangouts I want to try, but it's already too much. All right, so I'm going to give extra credit if you guys can ask questions while I'm lecturing. All right, so hopefully I'll say something that doesn't quite sound right, and you can say, but what about this? Or ask me a question. All right, so.
Yeah. I know, they just said something to the camera.
All right, so the first thing to know about meta-analysis is it's not considered primary research, because a meta-analysis is a collection of studies that have already been done. So in that way, it's secondary. It's an author looking at somebody else's work. But it seems like it's primary research because there's a systematic methodology used. So definitely meta-analysis has some characteristics of primary source research and some characteristics of secondary research. But you could look at it as, why would I come down on the side of secondary research? Well, 2 reasons. One is that's how most people define it. But secondly, let's suppose all the primary research that's used, that's systematically analyzed for a meta-analysis is poor research to start with. Well, the final meta-analysis is going to be no better than the original research. So it is secondary in effect. It depends on the quality of the original research. And again, the place to download it from D2L is not in, you're going to have to go to the section in D2L under content that says resources used in class, something like that. It's down at the bottom of the list, and it's for March 4th. All right, so the methodology section of a meta-analysis, that's what the next bullet point is about. Generally, somebody who's doing a meta-analysis lays out the rules they followed when they were doing their meta-analysis. So the first rule is, how do they select studies to include in their analysis? And even before they talk about including studies, they talk about how do they search for studies. So often in a meta-analysis, they will say, these are the search terms we used. These are the sites we used to search. This is how we conducted the search, to demonstrate to the reader how comprehensive they were in trying to find all the published research that fit their criteria, right? Then the second thing they'll do is try to describe the criteria for including or excluding studies to be included. So they might say, for a study to be included in this review, they had to have random sampling. Now, almost for sure they wouldn't say that because there are very few random sampling studies done. Nobody's earning extra credit yet. You guys have to ask questions during extra credit. They might say there has to be a control group. Hopefully they would, because a lot of you have noted that that would be, one of the essential things. Hopefully they would require random assignment, but maybe not. Maybe because they would know that there aren't enough studies to do that. Maybe they would require that there was pre-testing done and that the control and treatment group were equal. And they might have a requirement about the kind of measurements used in the study. All right, still not getting a question. There's so much extra credit points out there, you guys can't even believe it. Now, what it does is it takes all these studies, it calculates, the author of a meta-analysis calculates the effect size from each and every study by the information published in that study. Sometimes the original studies will include an effect size calculation. Sometimes they include the information the meta-analysis author needs to do the calculation themselves. Really, they only need some means and standard deviations and a few other basic pieces of information to come up with an effect size for the study. Then they take all the different effect sizes, they have a fancy way of adding them up and coming up with essentially an average. And they'll say the effect size average for all of these studies was 0.3 or 0.4, whatever it was. And when Hattie has that list of different types of research that rank different effect size, that's what he's talking about, those averages for that whole content area. Robert, that's a great question. When do they decide what to do or not to, when to include or not to include? Well, I can't claim to have done this kind of research myself, so I can't speak firsthand. But it certainly seems like whoever is doing the meta-analysis would be well aware of the literature before they would do this kind of work. And so they would have a pretty good idea of what would be feasible to include as criteria. They're not going to be able to include the highest criteria possible that they would love to include if they already know there's a lack of research that includes those criteria. Right? All right, Betsy, great question. We're going to get to that. And Betsy, Molly, Kyle, you all have so much extra credit right now. So Betsy's question is about effect size. So hold on to that question, Betsy, because that's what we're going to spend quite a bit of time working on. Not just a definition of effect size, but trying to understand what it really means. Molly, that question is a good question, but really the answer is I'm sympathetic to that question, that it should be primary, but really the fact is it's considered secondary. And the question from Kyle, will different types of data collection methods affect the final data? Absolutely. So in the Slavin article that you just read on technology, the primary emphasis there was on control groups and things like that, the research design. But data collection is just as important. All right, so I'm going to go through a few of these points here in a little bit more detail, and they're the kind of things you've been responding to on D2L. So I don't think I'm going to go real deep into it. All right, this is one that was not dealt with very directly. It was in the article, but not very directly. Just take a second and read that. All right, so this is, in my mind, this is huge. So there's 4 studies done on a particular innovation. 3 of them find that the innovation was not effective. 1 of them finds the study was effective, and the one that's published is the one that found that it was effective, right? So for the individual reader reading that study, they're going to think that that's what's been found, when actually only 1 in 4 times was that found. So by the way, my source here is Wikipedia, and actually there was a source cited within Wikipedia for that statistic. And I don't believe there's any real, positive proof way of demonstrating this. I'm sure that there have been clever ways to try to uncover how often it's true. It's kind of like proving a negative, but my personal experience is that this is the fact, that when people are doing research and they early on in their research, they're seeing that they're not getting any positive result, they decide not to go for publication. The belief is that it won't be published. This particular article by Wikipedia seemed to say that that wasn't necessarily true. It's more a belief by the authors, but I do know this is a common belief among authors, and so I tend to believe this. And since I've spent so much time this semester trying to develop a critical lens about things, you might wonder why I'm quoting Wikipedia, and I'll just say now, without trying to back it up, that I actually think the peer review process in Wikipedia is better than the peer review process in most educational research journals. So how's that? I'll back it up a little bit. And on topics that I do have a little bit of knowledge of, that I think I can detect whether or not the article is well written or not, I usually find myself thinking that what I find in Wikipedia is very, very sound and consistent with the research that I know. All right, you need pretest equivalence in any studies that are included in a meta-analysis, ideally, and a lot of you resonated with this, right? This is the one where you don't know what happened in innings 1 and 2, so one team might have won after inning 2, but you don't really know who won if you don't know if they started out equal. All right, this one is very interesting to me. Sample size, and a lot of you talked about sample size in your D2L. Let's see here. So when they had 30 small studies, they had an effect size of 0.26, which is small to moderate. But compared to large studies, the effect size is only 0.12, which is very small. So having a large sample tends to mean you're going to get a smaller result. And I would just invite anybody now to possibly say why they think that might be true. Why would large studies get smaller effect sizes? All right, so I'm getting a lot of good thoughts here. Now, first I have to say, there's no good answer. There's no right answer. I can't prove an answer to this. But let's talk about some of these that have come out. Sarah said lack of outliers. So that's a possibility. If there's a number of small studies, they could be like the outliers. And one outlier, one small study with a big effect is going to, on average, mean that there are more. But so then I might wonder, though, couldn't they have outliers in the negative direction? And then you might go back to the question of not publishing those studies. So you get these small studies that have extreme results, positive or negative. The negative results are not published. The positive results are. And so on average, what gets published is a higher effect size for small studies. The large studies, on the other hand, if you do a large study, that publication bias is not going to be as is not going to come into play as much, because there's a lot of money that goes into doing a large study and a lot of work. And after people have done that, even if they're not finding results, they're more likely to publish, and they're more likely to have confidence in their negative finding and think that that's interesting and something people should know. Just like the study that we read last week on the Compass Learning. It was a very large scale study that found no effect, but it was published. All right, Robert said because you have less control over other variables. To me, that's a very likely reason as well. So in a small study, maybe you can imagine one teacher or two teachers with 2 or 4 classrooms being studied, and everything about the implementation is done precisely. And the best theory is used in implementing whatever the innovation is. Let's say it's cooperative learning, to go back to an article we already read. And you know that cooperative learning has many principles that have to be done correctly or it doesn't work. And so in this small scale study, the researchers are actually like extra hands that help in the classroom, making sure that everything is done right. But when you implement cooperative learning on a large scale, people are going to do it their own way. It's not necessarily going to be best practice. And so it's going to be really a threat to internal validity, but also real life. So you can't decide I want to do cooperative learning based on some small studies where it worked, because as soon as you scale up, you're going to lose the effect. So Frank said something similar. People not participating, researchers not being able to control this. Possibly, but it might be, it's hard to say whether those people that would drop out, for example, from a study would affect it in a certain direction or not. More variance in the data, that's kind of the same answer as the spread out answer that Kyle gave, and also similar concept to the outlier question, outlier idea. And Holly's saying large studies are going to have more people keeping the average low. But Holly, if you get a chance to answer this, why wouldn't there be just as likely the number of people on the negative side as on the high side in a large study versus many small studies? Okay, Holly has the same kind of idea about outliers. Okay, so basically we're getting two different answers. Outliers, small sample size, means you're going to get unusual findings. And the other answer is lack of internal control. Both could be the answer, but I'd say if you're going with the outlier answer, you have to combine it with the idea of publication bias, because you could get just as likely, we can imagine that those don't get published. Right. So as I'm going through some of these reasons, they apply to the effect size that you would find in on average in a meta-analysis, but they're also good things to be asking about individual articles. So if you've got an individual article and it says that whatever your innovation is that it had this great effect, but it was only 30 people, that might be something to question. Would it scale up? All right, so we got the pre-test equivalence, sample size. No control group is kind of obvious, but what's really important here is look at how big this effect size is. We're going to read something later about effect sizes this big. There's really only been one thing ever in the history of educational research to find an effect size this big that's legitimate. So that's huge to have a 1.83 effect size with a no control group versus 0.18, which is small. So, you know, having a control group is not just like good practice, it completely makes the difference of whether the findings are legitimate or not. Short duration study, larger effects. This kind of goes back to the small sample size, although it takes out that outlier argument. With short duration studies, I think the only thing that's coming into play is more control by the researchers, or possibly a greater Hawthorne effect. You know, like it's an intense week and everybody knows there's an experiment going on, or more bias from the researchers. So there's an effect that's going on in a short-term study that's hard to duplicate or extend to larger-term studies. All right, so those are some of the main points, and now I want to go back to I think it was Molly's question, or no, it wasn't. The question about what is the definition of effect size. All right, so we're going to do an activity now, and this is going to really test us, where we're going to try to understand what different effect size means. what I want you to do is download the agenda from D2L. Many of you have been finding the PowerPoint on D2L. And the agenda has some worksheet kind of work on it. It was Betsy. Where you're going to find the agenda is on the content section of D2L under materials used in class March 4th. And once you get there, just kind of stay there because we're going to use a bunch of things from this list tonight. And the text is going to be really small, so I'm going to screen share it now, but I don't think you guys are going to be able to see it from the screen. So you really want to download it. All right, let me know when you're on today's meet and you've got it downloaded, the agenda. It is a worksheet kind of built into the agenda. Download the agenda. It's called Agenda Research Methods, March 4th. Yeah, I would say, yeah, Robert, definitely novelty effect on short duration studies as well. Emily, that is not a silly question, but it's a hard one. I don't think I have a good answer. Okay, awesome. You guys are getting the agenda, that's good. All right, now here's the hard part. I actually want you to work with somebody else on this. Yeah, I know. We're already having enough trouble with this. We're starting to get it going. Let's see. I kind of had a list of people that might partner up, but not everybody's here, and I'm not sure how we can do it. And I have 3 different ideas for how you can partner. Actually, I have 4. All right. So one idea is you could call each other on your cell phones or something. Another idea is you could Skype. Another idea is you could Google Hangout if you've done that before. But a new idea is that you would use something called Firefox Hello. And I put the link to that up on the main page of D2L. Don't try to do any of this until we get going here. Firefox Hello is pretty cool. I just saw it today for the first time and used it today for the first time. It's like Google Hangout, it's like Skype, but you don't need a special app, except you do need Firefox. And you don't need to sign in. You just start it up, it creates a link. You send the link by email to whoever you want to share with. They click the link and the 2 of you are video conferencing. It's pretty cool. All right, so I'm going to get us started as a whole class with the activity. make sure people know how to do it, and then ask you to partner up, and you're going to go off as partners and kind of work on the activity for a while and then come back. Okay? So I'm looking at, I'm not going to screen share because you're not going to be able to see it anyway, but I'm looking at the worksheet myself. And you should be looking at the worksheet now. Right? So in this activity, there's a few things you're going to have to do independently. And if we were a whole class, I would ask you to do them, and then I'd give you some more directions. But I want to take us through all the directions now. All right, so you remember from the original video from the first night of class that John Hattie says he wants an effect size of 0.4 or better before he thinks it's worth paying attention to. And that there's a lot of educational ideas like small class size, like charter schools, like technology, that people spend a tremendous amount of time talking about as the main focus of policy, when actually they have very little effect compared to other things. And he thinks that what we need to do as a profession is just pay attention to the big things. So I want you to have a sense of what this means to have a 0.4 effect size or 0.2 effect size or a 0.8 effect size. And that's what the purpose of this activity is going to be. So in a little bit, you're going to do some hand calculations, estimating what happens with a 0.2 effect size, 0.4, 0.5, 0.8. But also one that has a 2 effect size, not 0.2, but 2. In other words, 2 standard deviations. And I'm going to have you read an article, just the first page of an article, that talks about the only innovation that's ever been found that does create a 2 standard deviation increase. Okay, so it's not hypothetical that there's such a thing as a 2 standard deviation increase, even though 0.4 is considered good and 2 is off the charts. There's one innovation that has been found and has been replicated that has a 2 standard deviation increase. So I want you to know about that to see that this is not completely just a made up number. Right? So I'll tell you when to read that article and use it as you're filling in this sheet. All right, so if you scroll down to the second page of the handout, and in case there's a delay here, I'm going to wait a second while you scroll down. And what I'm looking at now is the table. Test score, 57, 65, so forth. Okay? Let me know you're looking at the table. And I'll continue talking, but if I don't see people telling me in the next few seconds, I'll then wait a little bit. All right, so these are some numbers I made up that might represent the results students might get on a regular test that you would create as a teacher and give to your class. I think if you look at it, you might agree that these are reasonable numbers that some teachers might get for some of their tests. With a few A's, a decent number of B's, quite a few C's, a few D's, and an F. And I created this data set so that it has a nice average. It's exactly 78. Thanks, guys. I see that you see the table. It has an average of 78. I calculated that in Excel. And I was working to get the standard deviation as close to 10 as I could to make it easy to calculate. All right, so these are real numbers based on this data set. The average is 78, the standard deviation is 10. So if you remember, the calculation for effect size is, it's really like a z-score, where when you're talking about 0.2, you're talking about 0.2 standard deviations. That's how much better the treatment group did than the control group. So I wish I could write on the board right now, but the formula for effect size is, in the numerator, it's the treatment outcome minus the control outcome, and then you divide by standard deviation. So what we're saying is, suppose a whole class moved up 0.2 standard deviations. What would that mean? Well, since the standard deviation is 10, what would 0.2 standard deviations be? I'll let you answer that on today's meet. We're looking. So I'm waiting for an answer to how much, what's the number that you get. What is 0.2 effect size if standard deviation is 10? And repeating the formula again, it is treatment minus control, average outcome, divided by standard deviation. So I'm trying to imagine, like, this is my control group, and now this is going to be my treatment group. I'm going to see what a treatment group looks like that has a 0.2 effect size. And I'm seeing a number of people are telling me 2. That is correct. So in other words, we're saying 0.2 times 10. That's an effect size of 0.2. So what it would mean is, now it doesn't really work this way in practice, but on average it does, that every single score in here is going to increase by 0.2 times standard deviation of 10. So every single score in here is going to increase by 2 points. And actually, I'm thinking, let's do this individually. I really wanted to do it together in pairs, but it's going to be too hard. Let's do it individually. So what you're going to do is add 2 to 57 and get 59. Add 2 to 65 and so forth. Right? And you're going to do the same thing for these different scores. There's another table down here that looks at, well, what is the control group in terms of how many A's and B's? What would the treatment group look like that has a 0.2 effect size increase? What does the treatment group look that has a 0.5 effect size increase? So in the control group here, I'm counting 1, 2, 3 A's. I'm using a standard 90 to 100. So I've got 3 A's. I've got 1, 2, 3, 4, 5 B's, and so on. Right? Sarah, it sounds like the z-score formula, and that's why I spent so much time on the z-score formula, because the z-score formula and the effect size formula are almost identical. And in my mind, it's easy to understand the z-score formula because it's so concrete. It's about a single score. And now we're just taking one small step up in thinking about, well, it's not one score compared to the standard deviation, but the difference between 2 averages compared to the standard deviation. So what I want you to do now is individually fill in this column here by increasing each of these numbers 2, and then count up how many A's, B's, C's, D's in the control group and how many 0.2 effect size would have A's, B's, C's, and D's. Okay, get it? So like the 89 is going to become 91. So right away I know there's going to be at least one more A after we have a 0.2 effect size increase. And when you're done with that first column and the first 2 counting up the A's and B's, post something that lets me know what you're finding. Okay, so Frank's saying there's now 5 A's and 4 B's. Robert's saying there's 7 C's. Matt said not a big change. Okay. Is that Sarah? Sarah that says I got an increase of 1A, a decrease of 1B, so a B went to an A, 1D went to a C, and same D's and F's. Okay, so okay, based on the posts I'm getting it's making sense to some of you, and some of you, quite a few, it's still not making sense. All right, it is hard without a board. I'm going to give you a visual representation of it, and then I'm going to go back and explain it again. So if you look at the video now, I'm sharing a simulation of effect size, and I've got a link to this simulation, and part of the directions you're going to follow when you start doing this independently is going to have you use this simulation. So I've got a slider here, and it changes these graphs. So take a look at this graph here, and this is the normal curve that we've seen before, where this is the mean, and one standard deviation is here, and one standard deviation is here. I'm not sure you can see my cursor. Yeah, you can. Okay, so you've got, what is it, 68% of the candidates or of the data points are going to be between -1 and 1. All right, so now instead of having one group, let's say I have two groups. I'm doing an experiment. And the second group has a 0.2 standard deviation or 0.2 effect size increase from the original graph. So I can use this slider to simulate that. And there's a 0.1, and there's a 0.2. So one way of looking at this is the blue is the experimental group, the green is the control group. So everybody's kind of sliding over and getting a little bit better, right? Somebody that used to be, let's say they were at the average before, if the same person is the average person in the new treatment group, they're now doing a little bit better than somebody in the control group did. The people that are up here are doing a little bit better, okay? Now, if I was to slide this over to get ahead of us a little bit and say, what does 0.5 look like? Well, now many more people are doing better than did in the control group. And if I slide it over to 1, I've got now people that are at the average in the innovation, the experimental group, are now really doing about the same as people that used to do that were at 1 standard deviation above the mean. Remember, this is the 86th percentile. So if you think about a 1 standard deviation or a 1 effect size increase, one way of looking at that is that average students in the control group are doing as well as your 86th percentile students under normal conditions. Now, I don't know about you, but to me, 86th percentile, those are usually your A students. So now you've made your average students are your A students because of the innovation. So that's one way of thinking about how big the effect size is. Now I'm going to change it to 2 effect size, because I did say that there's one innovation in education that does that. And again, here's the average student under the new innovation with a 2 standard deviation increase. They are now doing as well as people used to do in the control group that were at 2 standard deviations. Remember, that's the 98th percentile. That's your A+ students. Now your average student in a 2 standard deviation increase is doing as well as students who were your A+ students. Your average student is as good as your old A+ students are, right? Under the innovation compared to the control conditions. So that's a visualization, and you're going to work with this in a minute. If you scroll down on this, there's some explanation about what this might mean in other ways of thinking about it, kind of the way that I was just explaining it. All right, so now I want to go back to the table and hopefully try this again and see that if it makes more sense. So effect size means how many standard deviations better the treatment group is than the control. Right? So if you add, because this is a 10 here, it's not just 2, it's because it's 0.2 times 10. 0.2 of a standard deviation. One standard deviation is 10. Add 2 to each of these numbers, that's like a 0.2 effect size increase. Some of you folks, let me know how you're feeling at this point. While I'm waiting for people to answer that question, Matt, your question is a good one, but what we're visualizing here is zero. I mean, is greater than 0 effect size increase. It is conceivable that there could be negative effect size for innovations, and actually there are some that, it depends on how you define the question, where they are negative. But most things we're looking at are going to be positive. Like, for example, if you looked at the effect size, there's a negative effect size to decreased income. All right, so I'm seeing some people saying they're getting it. That doesn't mean everybody's getting it. So let's do 0.5 together, and then I'll give you the directions to do the rest on your own. All right, so 0.5 effect size increase. Again, effect size, it's another way of saying how many standard deviations. So 0.5, this is a standard deviation, means there's going to be a 5-point increase, basically tacked onto each score. So what you're going to do now is add 5 points to each of these scores going down here. The average, by the way, would be 5 added 5 2, be 83. And the way I've got this set up, the standard deviation is still going to be 10 going across the board here. But add 5, count up the number of A's, B's, and C's, and this time what I want you to post is just how many increased, how many A's increased, how many B's increased, how many C's increased compared to the control. I don't want to compare to 0.2, I want to keep comparing to the control. So calculate 0.5, count up the A's, B's, and post what was the increase. Yes, that's right, Robert. Frank, when you say A stayed the same, are you comparing it to the 0.2 column or to the control column? I want you to compare it to the control column. So Sarah, I think you're doing the same thing where you're comparing the 0.5 to the 0.2. The 0.5 is always comparing to the control, because when we talk about effect size, these are different hypothetical treatment groups that each compare to the control. Same thing, Emily. You're comparing to the 0.2 column, not to the control. So in the control, there were 3 A's, and now under 0.5, there should be 5 A's. Okay, I think people are getting it at this point. All right, now I want to give you the directions, and I'm going to give you a bunch of things to do and go off independently probably. I'm going to stay online, both on the video and on today's Meet for questions or anything else. But for a little while, you're going to be working independently. So I'm going to give you these directions, and I'm going to ask you if you understand the directions. All right, everywhere it says as a group, ignore that. You're going to do it individually. All right, first thing I want you to do is go to Hattie's website. And I've got a link on D2L where to find that. Let me see if I can share my screen here. Well, instead of it, it's in the same place as everything else. So there's a number of links that you're going to use here under the materials used in class March 4th. There's the effect size simulation is the first link. When you do these effect size simulation changes with 0.2, 0.5, etc., I want you to use the same tool that I use where you drag it and you look at how it changes and then you read underneath what it says about it. One of the first things I want you to do is go to the Hattie rankings link. And that's going to take you to Hattie's list of innovations that are small, big, and medium, and large. And I want you to find some small ones that you might think of when you're doing the 0.2, some medium ones that you might think of when you're doing the 0.5, and some large ones when you're thinking of the 0.8. So I want to kind of make it concrete for you, what it means. And the third thing you're going to do is go to this article called Bloom. That's the author, and the title of the article is The 2 Sigma Solution. It talks about the only innovation that's ever found a 2 standard deviation increase. Before you start doing the rest of the calculations and before you play with the simulation, I want you to identify Hattie rankings that are at the different levels, and I want you to read the first page only of the Bloom article, because that tells you what the 2 standard deviation increase is. I want that to make sense to you, what that means and why it would make sense. I think it'll make sense to you once you read it. Right? It's very famous, and it's often compared to as the holy grail of educational research. Right? So you're going to do that, identify those things, and you're going to follow my directions from there. You're basically going to follow what we did with the table and this table and the second table, counting up the A's and B's, and then I have some questions for you to answer. Make sure the whole point of this is to answer those questions. And they're questions like, how would you explain this to somebody else? What does this mean in terms of specific Hattie influences? How would you interpret the 0.2 effect size, the 0.5 effect size? So that means you have to read a page of a journal article, you have to play with the simulation, you have to do all these calculations, and then post some answers on today's Meet about what this stuff is meaning to you. Right? So I'm thinking at least 20 minutes, somewhere between 20 and 30 minutes. Give me some kind of indication whether you understood the directions or not. And once you do, I'll let you go independently with us getting back together at 6:30. Russ, I see you got disconnected. You probably missed some of my directions. I'm waiting for people to tell me if they understood the directions, and then I'll explain them again after I get other folks started. Okay, Molly. Why don't you go to town, Molly? I'll see you back at 6:30. Same, Holly. Okay, Robert, Kim, Sarah, Frank. The simulator is a link on the March 4th. It says effect size simulation is the name of the link. It's on the March 4th resources that I have on D2L. Huh. Kyle, you need a plug. I don't know what to tell you, Kyle. Print out that sheet quick before it dies and get somewhere where you can plug it in. Can you do that, Kyle? Okay, Betsy. Main idea is to keep playing with these numbers and what they look like in practice and what they look like in the simulation, going back and forth till it's starting to make more sense to you and you could verbalize it. Hello, Josh. I just gave directions to a bunch of people and asked them if they understood, and a lot of them did. So they're off doing something now, and we're going to get back together at 6:30. So in just a minute, I'm going to repeat the directions for you and Russell, who got disconnected, and anybody else who didn't quite understand. And Josh, you made good time. All right, Josh, I'm going to start the explanation now for you and Russell and anyone else. All right, so a lot of stuff that you need to do this is on D2L in the content section. You have to go to the bottom of the list, not the Module 4 prep, not that one that we use all the time, but the materials used in class. It's at the bottom of the list. And you find March 4th. The first thing you're going to need is the Agenda Research Methods March 4th. That's a Word document. And in the Word document is, the typical agenda, but also, a couple tables and some directions for this activity. So you need to open that up or maybe print it off, and you're going to use that throughout this activity. There's also quite a few links that you're going to need. There's an effect size simulation. That's one of these slider graphing tools that helps you visualize effect size. So in the activity, you use the slider to see what effect size looks like, and you answer some questions. I also have you go to the Hattie website. There's a Hattie rankings link that what I want you to do when you get there is pick some effect size, so some innovations that have small effect size that could be around 0.2, some medium that could be around 0.5, some big ones that could be around 0.8. So we make these ideas concrete. Now, I also in this activity have you looking at effect size increases of two standard deviations. And I've been saying quite a few times tonight that there's only one known and replicated finding that has a 2 standard deviation increase in education. And that's a study and reported by Bloom called the 2 sigma solution. I want you to open that up and read just the first page. It's not necessary to read the whole article, just the first page where he explains what the 2 sigma solution is and gives it some concrete meaning in terms of what 2 standard deviations means. All right, So you got to get the access to all those, and then Josh, let me know in today's meet when you have access to that stuff, and then I'll explain the rest. Diane, you won't need to see the video. If you can hear my voice and you can download the materials, you'll be okay. All right, Josh. And Russa, are you still there? So while I'm waiting to hear back from Russ, Josh, you notice the directions for the activity are on the agenda. They're on the bottom of page 1 and they continue on to page 2. So ignore the part where it says as a group, you're going to do it individually. And I'll walk you through the first one. You're going to see what does it look like to have a 0.2 effect size increase, which another way of saying effect size increase is how many standard deviation increase is the treatment over the control. So this is my control group. It has an average of 78, a standard deviation of 10. I'm on page 2 now, Josh. You see the list of data points there. It's a test I gave as a teacher. Had an average of 78, a standard deviation of 10. Let's say I had an innovation and got a new set of test scores from a different class. What would it look like? So one way of seeing that is to say, well, 0.2 effect size increases, 0.2 standard deviations, in this case, 0.2 times 10 or 2. All I got to do is add 2 to all these scores to look like what it might be for my new class that's going to compare to the control group. And then to make it even more concrete, what I'm going to ask you to do is add up how many A's, B's, and C's and so forth this new effect size addition adds. So if I look at this, I had 1, 2, 3 A's in the control group, and I can see the 89 is going to bump up to an A. It's going to become 91. So I know I'm going to have 4 A's here. So I've already increased 1 A. Figure out all the A's, B's, C's, and D's, and so forth. And you're going to do that. You're going to look at the effect size simulator for a 0.2 increase. You're going to try to make sense of both those two things together, 2 different ways of looking at the same thing. Repeat the process for 0.5, 0.8, and 2. Be able to answer some of these questions. Come back to today's meet. We're going to be at 6:30, so you're going to have to work fast, Josh and Russ. You may not be able to get through it all. For a 0.2 effect size, you're going to, Emily, I'm answering you now. For a 0.2 effect size, you would add 2 to every number. For 0.5, it's 0.5 times 10 or 5, you would add 5 to every number. Thanks, Russ. For anyone else that's out there, if you have a question, go ahead and post it. Otherwise, I'll be doing whatever I'm going to be doing, looking at my email or something until 6:30. And I'll just be looking for your questions. All right, Robert, great question. Hold on to that question. We'll see who else has ideas about that. Emily, for the, yes, what I want you to do is look at the Hattie website and think of at least one or two concrete examples that would be point two. So when we are looking at what a 0.2 effect size increase, I want to be able to connect it to something tangible, a tangible kind of innovation. And Robert, I reread that article this morning, and I think I know what you're referring to, but I have to look at it again to remember. That's right, Frank. Robert, I do understand it now, and I will explain it later, but it also goes along with the question you asked before, I think, or that came up earlier, so I'm going to wait till we're all together. And Betsy, correlations, sorry to say, I mean, I'm going to explain the specific correlation that was just asked about, but more about correlations is a few weeks away in our class. But for the short term, you can think of pairs of numbers, two numbers that go together, like socioeconomic status. You could have a number for socioeconomic status and achievement, academic achievement. Every student has two numbers, socioeconomic status and academic achievement. And what would you would do it, look at those pairs of numbers and say, do high socioeconomic status numbers also seem to have high numbers for academic achievement and low with low? That's what it means to have a correlation. How often do those pair of numbers go up or down together? And p-values is for, really, we're going to work on it leading up into the next class, which is 2 weeks from tonight, Betsy. It's in the inferential statistics chapter. Hey, Robert, if I don't follow through and answer that question, ask it again, all right? Hope it's just your computer, Kyle. Well, Josh, we got 5 more minutes, but I have no idea if my sense of time was right in the first place. So others might be done at 6:30, or I might give more time. So just be listening to see what happens at 6:30. Josh, you should do the reading, but maybe not right now. It's extremely interesting. It's like really good thing to know. But you don't have to know it to do what we're doing here. That's an interesting point, Sarah. Josh, I'd have to go back and look at that. I'm not sure. I got too many windows open right now. There are quite a few good simulations on that site, though, Josh, you might want to check out. And if you want to make sense of the p-value simulation, that would be great, because it confuses me. Yes, there is a confidence interval part to this, Josh. So we're looking at just effect size, but in this site, they're looking at, well, what probability is there that it is an effect size of a certain amount, and how can that be interpreted? All right, it's 6:30. How many people, let me know if you're done or if you need another 5-10 minutes. Tell me how much more time you need. All right, thanks, Caitlin, Molly, and Holly. And lots of you. Okay, good. Good. All right. So let's go on to the questions. First question, let's get concrete here. What were some of the Hattie innovations that you were thinking about or picked to represent the small, medium, and large? For those of you who are just coming back in, I've asked the question, what Hattie innovations did you think of for small, medium, and large? All right, good. I'm glad somebody picked class size for small because we're going to come back to that one. Individualized instruction is an interesting one. I don't think that means the same as tutoring. I think that means like computerized instruction that's that adapts to the learner. All right, I'm seeing a lot of good ones in different kinds, not just teacher instructional strategies. All right, so next question. Tell us in concrete terms what you found with a 0.5, a 0.8, and a 2 sigma size increase. Now, I don't know how you're going to tell us this. Maybe you're just going to focus on the A's, how many A's you got at different levels, or maybe just the F's, or maybe some more qualitative way of explaining how big 0.5 is or how big 0.8 is. Point 8 classroom behavior, that's an interesting one. I'd like to see that meta-analysis. I saw an interesting one the other day that I really want to follow up on that says 0.7 effect size increase for removing a disruptive student. That would really change the way people look at things. Homeschool programs, was that your high one, Sarah? That would be interesting. There is a lot of positive literature about homeschooling. Okay, Caitlin, that's a good way of explaining it. At 0.5s and higher, the F's start to disappear. They do disappear at 2 sigma for sure. That's a good way of looking at it. All right, Robert, that's a great way of looking at it. You're explaining well what the curve looks like. All right, so you're seeing it the same way that Caitlin's looking at it. And that's a good way to look at it because a lot of what we do in education is, well, I should say no child left behind is basically that idea, not necessarily raising the A's up higher, but of bringing the bottom up higher. 2 is huge, yeah, and double the A's. Well, more than that. I counted 14 A's, I think, with 2 standard deviation increase out of 18. What did I calculate? I got 15 A's and 3 B's out of 19. Double the A's for 0.8. All right, so some of you are probably still typing this answer, but I'm going to ask just verbally kind of a follow-up. So Hattie says 0.4 is his dividing line. He says if something's less than 0.4, hey, it might be nice, but it isn't all that important, and there's other things that are more important. So what we should concentrate on is those innovations that have 0.4 or greater. Based just on the numbers that we're calculating now, Would you set the benchmark at 0.4? Would you set it higher or lower? Sarah, this is not about grading on a curve, really. This assumes that there is a normal distribution already, and the students are going to move up to a whole higher point when you do something that is considered better teaching. I'm seeing a lot of good answers here, and so many things I want to reply to from the thread that had preceded. All right, so I want to reply to what John said because that is a great point. It kind of depends. So in my example, I made up some test score data, and a 0.4 increase on that test would be nice for sure, but maybe it's not an important test. And maybe it's easy enough to do something to change that test. But something like the Keystones, that's a big assessment that is really hard to prepare for. It's not a 1 week intervention, it's a whole year intervention. And maybe 0.2 on something like that is pretty good. So it does depend on what we're talking about. Bigger assessments that are harder to affect, maybe a smaller effect size is more reasonable. It goes back to what we talked about earlier about meta-analysis. The larger their innovation, the longer period of time, the harder it is to have a big increase. So you have to take that into account as well. Sarah, you're making kind of the same point here, you and Kyle, and thanks for being on the phone with Kyle. And say hello to Kyle for us. That I'm glad he's still alive, even though his notebook isn't. Yes, you have to consider effort versus reward. So I think that's the point about a small test maybe takes a little bit of effort to increase it. And so maybe we want a bigger effect size there. But if we're talking about something big, the earlier example was Keystone tests. That's a bigger reward and maybe takes a lot of effort to get there. All right. Now I want to address actually one more thing. This is going to be really hard because I don't even know how I would answer this question. And maybe you want to answer a slightly different question. The question is, how would you explain this idea of effect size to somebody else? I picked 0.5, but just how would you explain effect size? What does it mean in practical terms? When you talk about effect size and a meta-analysis and a finding of a certain effect size, how would you explain that to another teacher? Great point, Sarah, about cost of implementation, yes. If I can get 0.2 and spend $1, great deal. But if I have to spend $10 million to get 0.4, maybe I'll go with 0.2. Interesting thing though is a lot of the most effective things are free, just like love. That's a good way to start, Josh. And you did start us out here, so let's see what others have to say. That's very accurate, Caitlin. Yes, that's right, Nicole. That's right, Molly. That's a more precise definition. That's right, Dean. Going back to worms and caterpillars, Dean. So it's a way of comparing worms and caterpillars and how big the effect is for experimental studies. That's right, Amanda. Amanda, have I seen you on logged in here? That's it, Matt. Okay, so a lot of you got it. All right. So I'm going to go on to a couple of questions that came up earlier. I wonder, you don't need to answer me, but just think about it for yourself. Did it bother you when you were filling in the table and you were getting a lot of values that were over 100, and the way I had set up the question seemed to indicate that I was using a test that scored out of 100? I was hoping it would anyway, and a couple of you did raise that question. So you said, you know, can we put in values that are over 100? Basically, the answer is, on the way I set it up, no. There's going to be some maximum score, or in tests where there isn't a maximum score, there's some kind of ceiling effect. Whereas you get near the top, you really don't make increases for those students that are at the top. So I was kind of misleading you where I had you add the same score to everybody. That's not how this stuff usually works in practice. Okay, sorry, Amanda. Take a look at the video if you can, and I'm displaying a chart that comes from the Bloom 2 Sigma study. Their normal curves didn't shift over to the right in a nice, neat way. What they did was they brought the bottom up a lot more than they brought the top up, so that everybody's bunching up near the top. And this is actually what happens with a lot of educational innovations. It doesn't raise everybody up the same. It usually brings the bottom up more than the top. Right? Do you see that? This is the 2 sigma increase. And here you've got, look at, this is the mean. And I don't know what this is, but this is like the mean is now at the 98th percentile, what used to be the control group. And that seems, you know, crazy. That seems, how could that possibly be? But if you think of what it means to get one-on-one tutoring, where every time you have a question, there's an answer, or somebody to ask you just the right question at just the right time, it's such a more effective way of learning. I sometimes think of, you know, parents that work with their kids in intense ways. Their learning is just so much more effective than whole classroom learning. It explains why Sylvan Learning Center and other places can make claims like, we'll raise your child's grades 2 grades. They actually can. They don't have some magical way of teaching. It's just that tutoring is so much more effective. And it's especially effective with those students who are struggling. Because what happens in education is there's some students that kind of are independent, and they come up with their own ways of their own strategies, and they sort of need a teacher to help them get them going, but they don't need the teacher as much as other students do. And so those students aren't affected that much by educational innovations, but most educational interventions are really about bringing this group of students up. One of the most important educational innovations that has come out in the last, it's not an educational innovation, but one of the greatest findings about educational innovations is about formative assessment. And where is it here? Oh, shoot. All right, well, anyways, I do know that this is the same kind of effect that formative assessment has, that it brings up the D's and F's a lot more than the A's and B's, because the A and B students, they're always asking themselves, do I understand this? Where am I confused? I have to ask a question now because I'm confused. The students that are at the bottom, that's what they don't do. That's why they're at the bottom. So if you're doing formative assessment, you're going to bring up the bottom a lot more than you can bring up the top. So I don't want you to do it now, but if you were to go back to that table you'd already completed, and instead of adding 2 standard or 0.8 to everybody across the board, you might have to take some of those points that you gave to the people at the top and give them down to the people at the bottom. And I think that would even make a more dramatic increase in what you'd find. All right, so this also goes back to a question that Robert asked about the reading from Bloom, where there was some words there about the correlation between aptitude and achievement. What they were explaining, what they were saying in that article was that in general, there's a strong correlation between aptitude and achievement. People that are high in aptitude before teaching are the students who achieve more. You know, your top students achieve more. But when they did the tutoring innovation, that correlation disappeared because everybody was achieving more. You couldn't predict at the beginning that somebody would not do well at the end just because they had prior poor aptitude. In other words, it was just as likely for somebody with poor aptitude to get an A as somebody that had high aptitude. It completely made, not completely, but it almost completely made the connection between prior aptitude and achievement go away. All right. So now the second thing that I wanted to bring up from previous questions was, what about this class size thing? We've got Hattie saying class size is not very important. And we've got this Bloom article saying class size, you know, when you get down to one-to-one tutoring, is the most important. It's the only 2 sigma increase effect that's ever been found. Well, that really leads to an important point. And I don't know if you can see the text here. I'm going to increase it. When you're talking about effect size and Hattie's idea about 0.4 and this innovation is good or that innovation is bad or whatever, you really have to break it down a lot of times. So Hattie doesn't do this. He just gives a round number for a general effect of an innovation. But Hattie himself, if you dig in a little bit, says a little bit more about class size. So the research on class size is fairly consistent that says there is no effect of decrease in class size, but those are studies that are done where they're comparing class size changes from the 30s to the 20s, or actually really when you read the studies, a lot of them are about going from 27 to 22. People study those kind of differences because those are the kind of realistic differences that schools might make. They might be saying, we can afford to have class size at 22, we'll hire a couple more teachers, spread out the students a little bit more, and we'll do that versus 27. And so those are realistic choices that school districts make. And so people study that. And when they do that, they find no difference. However, Hattie also cites meta-analysis that say there are appreciable benefits once you go down below 15. Okay? Not really until you get down to 15, but go down to 15 and there are appreciable benefits. So, and I think this is even more true for younger grades. So you can't take the headline and just say, well, class size means nothing. You have to get down to the more specifics for a lot of the topics. And then, of course, the final one is the perfect class size for learning, at least academic content, probably not social learning, is a 1-to-1 class size. 1 student, 1 teacher gets you a 2 standard deviation increase. Okay? So when you're looking at meta-analysis, most of your meta-analysis will break down the big idea into smaller themes and give you effect sizes for the smaller themes. Right? All right. So here's what I want to do next. I want you guys to look at the meta-analysis from your own studies. I want you to look at what is the effect size from the studies that you've been reading on your own topics. I want you to look at the selectivity criteria from your studies. You know, did they have control groups? Did they have pre-testing? Were there equal pre-groups? All the points that we talked about earlier. And for Russ and Josh and maybe some others who came in late, you can look at those in the PowerPoint, or they're similar to what we saw before. And did they develop sub-themes? So did they say this part of the meta-analysis led to an effect size of 0.2 and this idea leads to 0.5? And what are the effect sizes? Right. So want to apply the ideas we've been talking about to your real articles. And I want to give you about 20 minutes to do that. So I'm going to ask you to do that and then come back in 20 minutes. So that's at 6:15. And report back on what you found. If you can possibly find a way to work with a partner from your group or a couple partners from your group, that would be great. If not, you can do the analysis yourself and make sure your partners know what you looked at when you come back. All right, so you've got till 7:15 to look at the meta-analysis from the study in your own topic. Let me know if that's clear. Really neat that you guys are figuring out ways to connect with each other. Good development of sub-themes. What I mean is, like, let's say you were reading, I'd have to look at your specific article, but let's say you were reading an article on class size. And it just demonstrates over and over that there's no effect on class size, but doesn't develop a sub-theme that says, well, class size above 20, class size above 15, class size above 5. That would be a sub-theme. Or if I'm thinking of technology, there are different kinds of forms of technology. One, for example, is programmed instruction, where students get multiple choice items. They answer the multiple choice items, gives them a score, and that either they go on or they don't. That's one form of technology. And another form is a simulation, more like the graphing thing that you just did. And they're very different conceptually, and you can't just lump those two together. So a good meta-analysis on technology might have a sub-theme about what is the effect size of simulations, and another would be what's the effect size of programmed instruction. Dean, what you're supposed to be doing is opening up the meta-analysis from your group's topic about coaching and leadership, and trying to see some of the things that we've been talking about tonight. Like, first of all, just identifying what is the effect size that's cited in the article. Are there some sub-themes around coaching, or is it all, or leadership, or is it only just one thing? And what kind of controls did they require for studies to be included in the meta-analysis? So Robert, are you looking at a meta-analysis, an actual study called a meta-analysis when you say that? Yeah, pretty much any meta-analysis should have an effect size. A meta-synthesis, a little more qualitative idea, not necessarily. I'm going to go into Zotero and see if I can find the study that you're looking at. So, Robert, you're in the classroom management group, is that right? And which study are you guys looking at? Yes, correlations are used as another way of doing effect size. It gets more complicated, so I didn't cover it, but it's used in an equivalent sense. However, I would be looking at that in terms of a meta-analysis, not a single study finding a correlation. No, Emily, it's not the amount of students being studied. It's how big the effect is on however many students have been studied. Yes, Frank. 2 quizzes when we come back. I had great quizzes ready to go. Do you think when we come back from break, we'll be done with winter? Okay, good. D equals 0.24. That's what I'm looking for. D is the letter, I guess you would say, that is used to represent effect size in the literature. Thank you, Josh. And your meta-analysis is 0.24 for what you report on the type of study that it is or the type of topic. Did they have subthemes? R is definitely also used in correlation in addition to what in addition for effect size, in addition to what I have been describing. So now you're on the right track, Sarah. Well, there could be a lot, Lauren, and there might be different effect sizes for different things. Just like in the Slavin article, he reported effect size for large studies, effect size for small studies, etc. So a good meta-analysis will report multiple effect sizes for different aspects of the topic. All right, interesting, Josh. My guess is that none of those really make a difference compared to the overall. All right, Kim, 0.235, great. Close to Addie's breakpoint. And what does that 0.35 relate to? I know it's leadership, but is there a certain kind of leadership style that is related to a 0.35 increase? Learner-centered classrooms, 0.31. Thank you, John. Now, isn't that disappointing? 0.13 for problem-based learning, especially since we spend so much time in teacher ed promoting problem-based learning. Don't you hate it? Frank, 0.55 for what? All right, so we got 0.55 for problem-based learning and 0.13 for problem-based learning. So you guys would really need to dig in then and try to figure out why those two meta-analyses are coming up with such different numbers. 0.31 learner-centered. I'm not sure if that's the same study as the other one that was reported, but it sounds pretty close. All right, efficacy and performance. So it sounds like the efficacy is self-report, perception, and performance might be some more concrete measure. So that makes a difference too. All right, we got another problem-based learning, 0.29. So this is a highly studied area, obviously, where we got multiple meta-analysis. And that part of the job of your group is to figure out why they're coming up with different numbers. And I have an interesting list of effects that compare problem-based learning to some other things. I think the issue really for you guys to figure out is it's not problem-based learning that's effective or not effective, but how it's implemented. And one of the things you're going to need to look at is how is feedback part of problem-based learning? Because feedback has a huge impact on learning. And I think there are forms of problem-based learning that are weak in feedback and others that are stronger. All right, nice, Lauren. That's a clear relationship there. Again, it sounds like it's self-report and perception, which is probably, at least in my mind, a little weaker kind of measurement, but it's what you would have on this. All right, so I don't know, I hate to ask this because this has been a bulk of what tonight is about, and we're going to go on to one more thing. But before we do, I wanted to get some feedback on how the learning has been so far. I know it's not been as efficient as if we were face-to-face. I think we could do things a little faster. But how have you felt about whether you've made progress in understanding tonight? Strong, could explain it. Medium, sort of got it. Or the topic and the means of teaching are making it very confusing tonight. I don't know if you did, Nicole. And I wouldn't, yeah, these are kind of lowish. Yeah, I agree. I don't know that you picked high on Hattie. We'll have to go back. I'll bring the book. Or you could look at his website. The book is better, though, because you get the exact citations. Also, another thing to keep in mind, Nicole, is what we talked about earlier. It depends on what kind of thing that you're finding. So a 0.27 effect size for a minor improvement, I mean, a measurement that's kind of a small thing is not that great. But if it's for something like reading comprehension, which is so hard to impact, then it's bigger. So you also have to look at the measure. Okay, Robert, but I got to go back to Caitlin now. I can't find her. Okay. Medium, strong understanding of effect size. Yeah. So we have to go back and find the study that was 0.72. All right, so I'm reading a lot of mediums, a few strongs, a couple medium, borderline, confused. I guess I'll take it, but I wish we were together too. And I'll have to tell you that I spent a lot of time thinking about how to prepare for tonight because I knew this would be a complicated, difficult topic anyway. So it's a little bit harder than when we can't really talk right immediately when we're confused or have questions. All right, we're going to go on for one more kind of new area here, and that is literature review. So the big topic for tonight is looking at the literature as a whole. Okay, you've all turned in analysis of a single article, and so that's looking at one article, and meta-analysis in a sense is looking at a lot of articles at once, but reported in one meta-analysis study. But literature review the big assignment that you're going to have at the end of the semester is also about looking at all of the literature together, but not just taking it from a meta-analysis, but you digging in and doing the research on many subjects or many studies. Okay, so I want to talk a little bit about literature review and something that I've been thinking about quite a bit. I got to find my right slide here. And that is kind of by happenstance. Sorry. By happenstance, on the first night of the semester, we started with an article by Slavin and a video by Hattie. And I've used that article by Slavin before. I like it as a good intro article for research. Hattie I haven't used before because, and I started getting into his work more because I was part of a book club last year that read his books. So I just picked Hattie kind of randomly, to be honest with you. I did know that I wanted to spend more time in meta-analysis this semester than I've spent in the past. But starting with both of those at the beginning of the semester has gotten me thinking about something completely new. Because I've realized over time that Hattie and Slavin are both well-known meta-analysis researchers, both very famous. I would have said Slavin is more famous, but nowadays Hattie's quite popular. He might be the most famous educational researcher out there now. Slavin's up there too. They got to be in the top 5 for sure, the two of them. But I think they're saying something completely different. And I'm going to explain it here, but if you have the PowerPoint, you might want to bring it up because I'm going to show you some quotes. And I don't think they're going to show up online. So for Slavin, research is about trying to prove things that we're not yet sure about. So there's some ideas out there that we may know a little bit about, may think we know about, but Slavin says the research hasn't been good enough yet. And so he wants more research to really prove it because we're not really sure. And Slavin also wants us to learn new things, right? He thinks we're going to keep making improvements in education by refining our knowledge and learning new things. So I think that's the idea I've had about research forever. It's the assumed idea, I would say. It's what doctoral programs teach about research. Like, what are you going to add to the knowledge of your discipline? What new thing are you going to learn? And I would imagine that that's the idea that most of you have about research. Like, what can I read that will tell me something new that I don't know? What has been, and this is why your professors will often say, I want studies from the last 5 years, because they want new information. They want what's the latest and greatest, because our field is about improving, right? And we can't improve by using what we already knew. We got to learn new things. So that's Slavin, and that's traditional. But Hattie is saying something completely different. Hattie is saying, we really just need to put into practice what we already know. Hattie thinks we know plenty already. And what we got to do is actually start forgetting some of the things that aren't important. Like, we got to stop thinking about class size because it's not important. And we got to pay attention to feedback. That's Hattie's #1 thing that he writes about in his book. He connects everything to feedback. If we could just understand feedback better, something we already know, and understand it better and put it into practice, that's the point. We do not need to learn anything new, really. I mean, I'm exaggerating a little bit, but that's kind of the difference. So if you have the, and this, I'm going to connect this to literature review in a minute, so hopefully you'll give me a break on this, that I haven't made the connection yet. You might want to look at the downloaded PowerPoint next for the next slide, and I'll read it. But this is a quote from the article that we read the first night of class. So Slavin has, to set this up and remind you how it works, he talks about how there's been these great breakthroughs in medicine and science. And he says that a lot of people say, well, you're not going to make those kind of breakthroughs in education because we're talking about human beings. We can't create a superior human being. We're just going to create, we can't do that. So you can't expect the kind of improvements in education that you've had in medicine and other fields. But Hattie feels like we can, but he's going to do it a little bit differently. So he says this: in these and hundreds of other cases, It's the accumulation of small advances rather than breakthroughs. This is how evidence-based policies will probably improve education. Once we have dozens or hundreds of randomized or carefully matched experiments, there will be irreversible progress. Apparently I got a little bit of that quote wrong. So Hattie believes we need new knowledge, we need better knowledge, and we got to keep improving. And if you read the meta-analysis that he presented, he's asking questions in technology. He's getting really specific. He says, okay, maybe we know technology works a little bit, but is it better if you do it 30 minutes a day or 60 minutes a day? These are the kind of questions that Slavin is asking. He's saying cooperative learning, well, we kind of know that works, but should you use heterogeneous or homogeneous groups? And he wants to come up with very definitive answers for every aspect of education, put all those incremental improvements together, and create the perfect educational system. That's Slavin. But read this quote that I took from an article by Hattie that really comes from a completely different perspective. Hattie actually says we already know too much. So I'm reading it for those of you that don't have the PowerPoint. There is so much known about what makes a difference in a classroom. A glance at the journals on the shelves of most libraries, my colleagues' shelves, and on the web pages would indicate that the state of knowledge in the discipline of education is healthy. The worldwide picture certainly is one of plenty. We now have a library solely consisting of handbooks. A handbook is a synthesis of all the research. So we have libraries of handbooks, most of which cannot be held in a hand. They're huge. Given this bounty, it would seem remarkable that there is much left to say. And then he jokes, that never stopped an academic. So we're actually publishing as a field a lot more than 10 years ago. There's a proliferation of journals and a proliferation of people publishing. But Hattie's saying, you know, you've already said it all. There, you don't need to say anymore. You've said it all. What you got to do is figure out what you've already said and what's important. So for Hattie, he wants to know what's the most important things. And some of the things he talks about as the most important are feedback and figuring out the appropriate challenge level for a particular subject and particular students. And what does he want to stop thinking about? Technology, class size, and charter schools. All right, so everything I've just told you is a completely new insight for me. That Hattie's point is stop doing research. Pay attention to what you've already learned. All right. Now, I do hope you have the PowerPoint. And this is, I'm going to make the connection now between Slavin and Hattie's perspective and literature review. So for you guys, you're doing a literature review. And would help to know the purpose of why you're doing it, right? Besides that you've been asked to do it by me. So there are really two, there's probably more, but there's two big reasons that you might be doing literature review. And one kind of fits the Slavin mode. It's what you would do if you were working on a PhD. It's what most people would coach you to do, and that is the way you do a literature review for publication. And the purpose of a literature review and publication is to demonstrate the importance of your topic and find the holes in previous research so you can propose new research to fill the holes. Okay, so remember Slavin says we need new incremental knowledge. So that means you got to figure out where we got holes now, explain it to everybody, this is what we don't know yet, and then say, well, I'm going to do a study and I'm going to figure out what we don't know. Right? That fits with the idea of publishing research. It does not fit well with teacher research, but I think Hattie does fit good well with teacher research. And I'm going to put a side note about participatory action research, okay? But just teacher research. Kyle's doing a master's thesis now on how to help students learn measuring, because he's noticed it's a real problem with students can't understand how to use a ruler. Basic fundamental skill, and trying to figure out why that's true. So this fits well with something like Kyle's doing or something like others might be doing. So if you believe that we already know the answers, then why would you do a literature, or why would you do any kind of research as a teacher? Well, the reason would be we know the basic principles from research. We know that feedback works. We know that problem-based learning works to an extent, but not as well as some other things. maybe it could work in combination with some other things, but we don't need to prove those things work. What we need to understand is, how do you give feedback in this particular curriculum with these particular students? So the Hattie idea is a marriage of research and practice. Research tells us the big ideas, tells us where we should be focusing our energy, but that doesn't tell us yet how to do it in the classroom. Now I got to take those big ideas and put them into practice. So if you're writing a literature review from the Hattie perspective, it's all about identifying big ideas and then trying to connect them to what might be done in the classroom to ask questions about the classroom. And not trying to prove everything, because you already know what the answer is. You just don't know how to put it into practice. So those two ideas of writing a literature review are pretty different, and they're going to come out different. Another thing about Hattie is the things that he believes in as the most effective are formative assessment, feedback to students, teachers paying attention to learning, and teachers working together looking at student learning. So if you think about the things that he already thinks are effective, that also fits with teacher research, because those are the kind of things that you're going to do for your data collection. Those are the reasons you would do research in the first place, is because by doing it and paying attention to the findings and adjusting your teaching based on the findings, that's what actually is one of the biggest things you can do to impact your practice. So Hattie believes that doing research by teachers is one of the largest effect size innovations there is. So Hattie fits well with teacher research, at least that's my argument, and Slavin fits better with research for publication, the thing that people are taught in PhD programs. All right, so I've been talking quite a bit, and I have couple last things to get you guys working on. We would have done this in groups in school, but I'll get you working on them after in preparation for the next 2 weeks. But I would ask you now, what questions have you had while I've talked about this difference between Slavin or Hattie, or where do you disagree with me, or where does it make sense to you? And I'm asking you for today's meet. Not yet, Robert. Molly, I'm glad one of the first posts came from somebody who disagrees, or at least says the other side. So when do you think that would be true, Molly? Actually, Josh, yes, that's one of Hattie's biggest effect size innovations. That's the word I'm using. Hattie argues that just trying something new is one of the best things you can do. And it may be the novelty effect, or it may be the effect of studying. Okay, Molly, I read your thing. It was kind of moving fast because other people were posting. Yeah, I'm still wanting to hear a specific example of the whole that you might be thinking of. The reason I'm asking is because I think it matters the topic, because there are things that we know more about than other things. Slavin is definitely concentrating on publication. There's no doubt about that. He's also concentrating on money for publication and research, which seems self-serving, although I do believe he authentically believes it, not just because it makes him money. All right, Nicole, you have a really interesting point there. Shake things up like Hattie. Don't try to invent something new. This is an idea I've been thinking about. Is Hattie a progressive or a conservative? Does he want to change things, or does he want to make things more like they should have always been? All right, so I've heard from quite a few of you. Maybe a few more coming in now. The formative assessment in English. John, I really do believe if you could implement it well, you would find the biggest increases in your outcomes for your students that you've ever found. Okay. That makes sense. I'm replying to Molly now about engineering as something new. However, there is the issue of the engineering curriculum, but then there's the issue of there are some standard things that we know despite the curriculum that are going to make a much bigger difference than other things. All right, so classics. Sarah, you're getting back to my idea about conservative or progressive. I think of Hattie like the classics, and that's conservative, at least in my mind. Let's go back to the classics. I think of Slavin as more progressive, incremental improvement and progressive change. You can go too far with what I'm saying, no doubt, but it's an interesting connection. All right, guys, thank you for responding to all that. And that's just a little thought to get you in the mind of what's the purpose of your literature review. When we get together as a group, you're going to have able to have a conversation about that. But for now, I'm just going to give you a couple points about literature review, and I'm going to add a little movie to your homework that we were going to watch in class, and just get you thinking about some things. So for 2 weeks from tonight, when we meet again for the next time, you are all supposed to have posted onto Zotero into your group space at least 10 primary source articles with some of your notes about those articles. And there's been some questions on D2L about how to identify our articles. I really do recommend that you create a tag for your name and add the tag to each one of the articles that's yours. Okay, and if you play around with Zotero very much, you'll figure out how to do that. You can type a tag for each article, or you can type the tag for one article and then drag the articles that are yours over onto that tag, or the tag onto the articles, and just apply them automatically without typing. But if you tag them, and you have 10 articles, say for Sarah, I click Sarah's name, her 10 articles will be selected for me automatically. And I can see she's got her 10 articles, and I can browse through her notes quickly. All right, so you're going to have 10 articles by next week. So each. And so your groups of 4, you're going to have 40 articles. You've got a lot of articles. It's time to start putting them together. And it's going to be time to start thinking about literature review. We're going to work on this together next week. But let me give you some big ideas here about literature review. All right, the first idea is you're going to, as a group, want to start broad. And usually this means connecting your topic to a larger issue in education. Okay? So I don't know, the groups that are doing relationship research, relationship, that's already pretty broad, but you might start with, the challenge of education in the United States, and people are bemoaning, the state of education. But, the transition would be something like researchers have proposed that we shouldn't just be looking at instructional strategies, but blah, blah, blah. So the idea is start broad because you want to connect with your audience and you want to connect to something important to your audience, even if your topic was not already important to your audience. No different than you would do for any, I'm sure you all learned in some writing class somewhere. It's your hook, it's your connection to purpose. 10 primary articles. Right, that's right, Frank. Yes, okay, I'm sorry, I'm getting distracted by your comments. I agree, Sarah, classics can be new too. So that's why I'm not sure if Hattie's a progressive or not. All right, anyway, start broad. Now, the next point is the most important, and this is what you guys have to really figure out as a group. You do not do a literature review by saying we study, here's study 1 and describing the study. Here's study 2, describe the study. You don't do an annotated bibliography, in other words. You don't go by article, you go by themes. So what you're going to have to do in your groups is figure out what are the themes within our topic. Teacher-student relationships, there are certain sub-themes, what are they? And then you start organizing your literature by sub-themes. Maybe you have 4 articles on theme 1 and 4 articles on theme 2, etc. Maybe some of your articles cross multiple themes and you might bring them up in your literature review more than once. So you report about those articles in theme 1, but you come back and report on them again in theme 2, along with a different set of articles. But the key is organizing your paper by sub-themes. And I should say, going along with this, you're trying to tell a story. You're starting broad with something that's meaningful to a large audience, and then you're starting to say, why does it, what are the parts to the story? And start to tell those parts. And in between themes, you make connections. So theme 1 relates to theme 2, how, and then what is theme 2, and what is the research on theme 2? You want to write in your own voice. So you're telling a story. We'll talk about whether you're talking in first person or not, but you want to bring your own voice in it. You're not going to give big quotes from your papers. Ideally, you may not have any quotes at all in your paper. You're going to take the main idea of the article or the main finding of the article or a key point of the methodology and explain it in your own words. And lastly, as a group, you're going to decide on what is the purpose of your literature review. Okay, so that's the literature review overview, and what we're going to do next time we get together is start to have time in your groups to identify sub-themes, think about your purpose, and start to get an idea of how your literature review is going to come into play. All right, we're about 10 minutes left, and I just want to end by asking what questions you have that you need answered so that you can be productive for the next 2 weeks about getting your 10 primary articles, or any other question that you have to end the night. Well, okay, that's a great question. The goal is to have minimal duplications. I'll say it like that. So you've been sharing ideas so far, and if 2 people have 10 exactly the same, that's going to be a problem. But if you do your best not to duplicate, that's what I'm looking for. No, it's not the Hattie video. It's another one that I'll have to add to the to the D2L because I was going to show it in person. It's a really neat video on literature review. I think it'll make it clearer for you. The answer, Kim, is the 10 primary articles are ones that you may use. So in the end, there is going to be a requirement that you use at least 5 primary articles from each person. So let's say you're in a group of 4, which you are, and you have 40 primary articles to choose from, or let's say you have 35 because there are some duplicates. In the end, you're going to need to pick at least 20 of them. And maybe you'll actually, 35, you still need a few more new ones because you don't have the right 35. But you're not going to necessarily use them all because you're going to figure out some of them are junk. And Betsy, I'll just say again that no duplications is the goal, but I'm going to be flexible. It's just make your best effort at no duplications. All right, we've reached the end, so I'm celebrating. I looked outside, it's raining and not snowing. I feel really more sympathy for superintendents and my provost when they make these snow calls. Many times I've said, oh, that person was so stupid. And now I have a little more sympathy because we probably could have gotten more done in person. But it said, winter weather warning. I don't know. What do you do? All right. Thank you very much for having patience tonight. Thank you very much for sticking with me. I'm going to stay online for a little bit longer and see if there are any more questions. But if you've had your question answered and you know what you have to do for 2 weeks from now, we can be done for tonight. And I will put a little more clear directions on the next module for the new movie and so forth before tonight. Thank you. Hey, that actually looks pretty good. All right. Oh, look at this. I can promote Google too. My John McEnroe Google headband. I needed to cover up this spot right here though. Wow, you could put on a graduation hat if you got the main idea tonight. All right, thanks, Robert. And thanks anybody else. I'm going to stay on for any other questions, at least for another 5 minutes or so. Thanks, Kim. When is Dr. Seuss's birthday? Hey, I learned something by tonight. I learned that I lecture longer when I'm just alone by myself. If I was lecturing in front of you all, I would have made them a lot shorter because I would have seen the looks on your faces, but I can just keep charging ahead. So I like this. It's so fun to hear myself explain my ideas to myself. Oh, it was Monday. Okay. Yeah, it was a cat in the hat. Actually, it's a little different than Cat in the Hat. I bet they had a copyright issue. But they were going for Cat in the Hat for sure. Oh, I just got that, Caitlin. You're saying you missed being in class because I lectured too long. Okay. All right, I got it. And truth, I don't know what you're doing, Robert. Truth. Come on. All right. I'm gonna sign out of Google here, but I'll leave today's meetup for a little bit while I'm working on some new directions for next week. That's true, Robert. I know, but it is kind of, it actually is fun to talk more without looking at people and seeing that they don't like what you're saying. It actually is kind of nice. The good old days. When lecture was acceptable.